So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. We're getting into the busy wildfire season here in California. There's lots of interest in battery backup systems combined with solar. And there's a lot of new technology developments. So on today's show, we're going to talk about the most important design considerations for battery backup systems when combined with solar. Now, first, why are we talking about batteries now? They've been around forever. What's all the interest right now? Well, there's three reasons. The first is that the batteries combined with solar save even more money than a regular solar system. And the reason is that electric rates are now most expensive in the afternoon and evening. They used to be most expensive during the day, but now they're most expensive at night when the sun's not shining. So the benefits of solar net metering, in other words, running the electric meter backwards during the day, are dramatically reduced. Also, the systems are less expensive and more reliable than ever before. Now, the second is the batteries combined with solar will keep the lights on and your food cold in a grid outage forever, basically. As long as the sun comes up the next day, your battery's going to be charged up from the solar. We're seeing more and more blackouts, both because of public safety power shutoffs caused by wildfires and also just ordinary blackouts. The grid just doesn't seem to be as robust as it used to be. And also, we're much more dependent on electricity than ever before. We're working from home. We have electric vehicles. Our homes are mostly electric right now. And in fact, codes are requiring all electric homes. Electric AC, electric heating, electric hot water, cooktops, everything like that. So, when the power goes out, our lifestyle kind of goes back to the 19th century. All right. So besides what's going on with costs in the grid, what's changed with batteries? Why is it taking so long? Well, kind of going back, Bell Labs demonstrated the first practical solar cell in 1954. And I remember back in 1999, there's something called Y2K, year 2000. The computers at the time couldn't really handle the changeover from 1999 to 2000. There was a lot of worry that the whole world would come to a grinding halt. So there was a lot of people putting in backup power systems in case the grid went down because of Y2K. And it turned out to be a tempest in a teapot. Didn't really happen. But about the same time, net metering became popular. Net metering is a situation in which you can store the value of your energy on your electric bill. So you run your meter backwards, and the utilities meter counts how much you're getting a credit for, and they give you a credit on your bill instead of storing energy in your own batteries, which were impractical because those old lead acid batteries were expensive and not that reliable. So basically, you didn't need batteries to get the value of your excess solar during the day, because you would just basically sell that electricity to the grid, go to your neighbor, and then in the evening, your meter would start going forward again. Now, from the battery perspective, the popularity of electric vehicles started to really drive down the price of big lithium-ion batteries. I mean, not only the little batteries that have been in our laptops for 20 years and our cell phones for 20 years, but big batteries that go into cars and bigger vehicles. Now, even more, in 2017, there's something in California called the Self-Generation Incentive Program that initially gave some rebates to batteries. And more significantly, a lot of battery companies came out with commercialized, robust, reliable battery storage systems. And we'll talk more about that in a minute. Then the fires that happened in 2017 and 2018, and then electric rate changes in 2019 made it even more useful to put in some kind of backup power system. And so people are kind of coming to the conclusion that they needed backup power, and solar and battery systems were necessary and cost effective because your alternative was it's too loud here. Let me go to a different room. The alternative was a noisy generator. And those generators are polluting, inconvenient, and they make a heck of a lot of noise. So here we are, and homeowners and businesses there's a high demand for batteries right now. So you could go to Amazon and buy a bunch of batteries. Buy a bunch of lithium-ion batteries. They're going to be cylindrical. Maybe you can get some packet batteries. You can get them. A lot of Asian manufacturers sell them. But that's not going to really help you. You can't just integrate these because the systems that reputable solar and storage companies are installing, it's not just a battery, it's a complete battery system. There's something called a battery management system that's usually tightly coupled, usually in the same enclosure as the battery itself. And this battery management system, we used to call it a charge controller on lead acid batteries, but now these battery management systems have more software and they're really well integrated. So these BMS battery management systems would control the rate of charge, how fast the battery charges, how fast you allow it to discharge. It controls the voltage, it controls the current, it kind of slows down the charging when the battery gets kind of fully charged. It also carefully manages the temperature in the battery because the batteries have different capabilities when they're either warm or cold. And they also make sure that the batteries don't overheat. The other thing that's built into the battery management systems, heck, it's the 21st century. There's software and everything. So there's communications that go between the inverter and the battery system, and there's communications that go from the customer, from the manufacturer, from the installer to the inverter, which then goes through to the battery. So there's firmware in there. There's the battery enclosures also include circuit breakers. It includes terminals, some safety capabilities, and mounting systems. Now, sometimes with these batteries that you see, like a Tesla Powerwall, there's an inverter built in. So it's a battery management system, and an inverter. Sometimes you just buy a battery that has a battery management system, and in that case, there's no inverter. You're able to use the same inverter that your solar system is using, and that's something that's popularized by SolarEdge. In addition, there's a enclosure. There's a box. There's a container that these things are put in where they're going to be safe, where they can be properly mounted either to the floor or the wall, and they're operated properly from an environmental standpoint. Most batteries are designed to be installed outdoors or indoors. So outdoor batteries have to have a fairly water-resistant enclosure. The ones that are indoors generally don't have the same protection against moisture, and that's why they're rated indoors. But vast majority of installations are better served with a battery that's installed outside the house or, sometimes in a garage. But the batteries, the popular batteries themselves, they're pretty heavy, 200 pounds. Why 200 pounds? Well, if it's 300 pounds, it's hard for two people to lift it. So 200 pounds is about the max that two people can carry. That's why. And they can be mounted on the wall or the floor. But there's really two big limitations of all battery storage systems. Really of all batteries, whether it's a battery in your electric vehicle or your cell phone or your computer. The one limitation is the energy capacity measured in kilowatt hours of the battery. Your cell phone is measured in watt hours or in your cell phone it's measured in watt hours. But the other limitation is the power output of the battery. It's measured in watts. So looking at the energy capacity, the most popular batteries on the market are rated at between 10 and 13.5 kilowatt hours. That's what you get for something that weighs about 200 to 215 pounds, 230 pounds. And you can kind of hang it on the wall or put it on the ground. That works out okay. When you need more energy, we're measuring energy in kilowatt hours. If you need more energy, you can put in two batteries. So, common to see systems that have 20 kilowatt hours or 27 kilowatt hours with two SolarEdge/LG Chem batteries or two Tesla Powerwall batteries. Now, let's talk about the capacity of these batteries. If it's 10 kilowatt hours, that means that theoretically it can supply 1,000 watts of power for 10 hours. It's always going to be slightly less because the batteries never go down to their zero charge level. They usually keep them down around, no less than 5%, so that the batteries can kind of jumpstart themselves and start up again. All right, the second limitation is watts. The popular inverter battery combinations have a steady state output of about 5,000 watts and a surge, that's the maximum peak for a few seconds, of 6,000 watts. The reason why you have this surge is that appliances with motors draw extra power during their startup. Like, for example, your fridge may use 300 watts when it's running, but it might draw 1,000 watts for a few seconds when it starts up. And big appliances, like an air conditioner or pumps, they're going to draw a lot of power over time. Electric ovens, they may draw well over 6,000 watts when they start. And also these big appliances keep drawing a lot of power. So your air conditioner, your EV charger, your electric oven, or your pool pumps can easily drain even a 10 kilowatt hour battery in like a few hours. And then you have no power at all, nothing left for essential things like your internet. So wishful thinking isn't going to make these limitations disappear. Marketing hype isn't going to make these things disappear. You hear of companies advertising, "We'll back up your whole house." Well, What good is that if the whole house is only going to be backed up for 45 minutes? That's kind of the clause. They don't really talk about that. You could get more batteries and you could get more inverters, and it ends up getting really expensive. And then you have limitations on the size of the electrical service. So the solution in this case is something called an essential loads panel. This essential loads panel basically provides power just to the things you really can't do without, the necessities of modern 21st century life. Your refrigerator, your freezer, the ice cream in there, the internet, your TV, your lights, maybe some convenience outlets so you can make a cup of coffee, your computer, things like that. It's only going to power those things. It's going to power them really throughout the night, and they're going to recharge during the day. But what it's not going to do is it's not going to power the luxuries, although some people don't consider air conditioning a luxury, but it's not going to power that, because if we were to try to power that, even if we could, it might only power it for an hour, and then you don't have any power for necessities. Now, first, let's talk about a regular solar system. This is how it works. During the day, the sun powers the house. The excess energy goes backwards through the meter. So if your house is using 500 watts and the system's generating 5,000 watts, you send 4,500 watts back through PG&E. And if it's like that for an hour, you get credit for 4.5 kilowatt hours. And that credit happens, it's a net metering credit, it happens at the retail electric rates. Now, it used to be that the daytime electric rates were expensive. 30 cents a kilowatt hour or more. And that was because there's used to be a lot of demand for electricity during the day for air conditioning. Companies were there, the sun was high, air conditioning was cranking, and that's when the state had to generate the most electricity. Now, with so much utility scale solar and a lot of rooftop business and residential solar, they changed the electric rates, which kind of logically makes sense. If there's an abundance of something, you can make it cheap. And if there's a shortage of something, you make it more expensive. Well, there's a shortage of electricity at night, and there's an abundance of electricity from the sun during the day. So daytime rates for electricity are relatively cheap, 16 cents a kilowatt hour on the EV or the electric vehicle rate. And the late afternoon and evening rates, when there's no generation from solar, the rates are 47 cents on the EV rate. So when you run your electric meter backwards during the day, you get a credit of 16 cents. I mean, you used to be able to get a credit of, more than 30 cents. But you're still spending 47 cents a kilowatt hour during the evening. So it's kind of flipped. And that's where the battery comes in. Instead of running your electric meter backwards at the cheap daytime rates, you can charge your battery during the day. So you're not selling power back when it's cheap. And then you use that battery energy during the evening and night when electricity is expensive. There's a 30 cent a kilowatt hour difference between cheap daytime rates and expensive nighttime rates on the current EV rate. That's the additional savings you get from a battery. Plus, if there's a power failure, your battery kicks in and you can power your essential loads. And that battery system will allow your solar to operate even in the daytime. So you're still able to kind of crank your solar during the day. So here's how the batteries work with solar. It's not just solar. During the day, the solar goes to the power of the house and charge up the battery. So depending on the size of the system and the size of your battery may be fully charged by 10 o'clock or noon or 2 o'clock. Everything in the house is powered during the day, both by solar and by the grid. And the excess during the day, once your batteries charge up, still goes back to the grid. So sometimes you get some credits at this relatively low rate. But when the power goes out, the battery system automatically kicks in, and the battery and the solar power essentially power the essential loads. And at night, the battery only powers the essential loads, obviously, because there's no solar. And we size the system so that the battery roughly matches the demand of your essential loads, even at night. So it all kind of works completely automatically. It's great. Now, there's several components in the system besides the battery. There's a monitoring system, so we can monitor the energy consumption of your house. And you can kind of see power kind of spikes in the morning when people get up, they take a shower, they make coffee. They not use a lot of power during the day if nobody's home, although shelter in place and COVID-19 has really changed that. And then power consumption usually starts going up in the evening when people are home, they turn the air conditioner on, they might do some cooking. So you can monitor that. There's an inverter that, that's what converts the DC from either the battery or the solar into the AC you see with your house. There's something called a backup interface. Sometimes that backup interface is integrated in the inverter. Sometimes it's a separate box. And this basically disconnects the solar and the battery from the grid in case of a blackout. So anybody that's ever kind of properly installed a gas generator knows that there's something called a transfer switch or an interface. And it does the same thing. When the power goes out, you may manually or automatically start your generator, and that generator, you don't want that generator backfeeding the grid. That's not safe, so that transfer switch automatically disconnects from the grid. Many inverters have that transfer switch disconnect device built into the storage inverter, and some systems have a separate box for that. And we talked about the need for an essential loads panel. That's just another ordinary electrical panel, usually with the 6 outlets or 6 circuit breakers or so. There's an auto transformer, and that auto transformer is sometimes built into the backup interface, and that just allows you to use the proper household current from both legs of the electrical service. There's batteries, obviously, and you have solar panels. All right, so let's talk about some considerations from selecting this equipment. One of the most important is making sure that the inverter that you're using is fully code compliant. There's something called rapid shutdown rules, which means basically that there's no high voltage on your roof from solar within, I think, 60 seconds after the system's turned off if there's a grid failure. And there's also something called California Rule 21, which is a very esoteric way of allowing the utility in certain cases to operate and control the inverter. So they make sure that all inverters are compatible with Rule 21, and the National Electric Code requires this rapid shutdown capability. So you got to make sure that the equipment that you're putting in is properly rated for this. It's not always that clear. Major companies obviously have that covered. You have to make sure that the battery is compatible with the inverter. Now, most inverters only work with one or a few different batteries. Companies like Enphase and Tesla have the battery built in. It's just you're buying a complete box. SolarEdge has a separate battery unit, and their inverter and their control systems will work with LG Chem batteries, and in the future, maybe 1 or 2 others. It's not like solar. With solar, pretty much all inverters work with all solar panels, so you can easily mix and match them. But with batteries, that battery management system has to talk to the inverter, and the inverter talks to the grid and to you, so you have to have good communications from the internet to the inverter to the battery management system, and they don't. That's why they're kind of not plug and play. The next thing is you've got a lot of software that's kind of buried in these things, and boy, it's just amazing how fundamentally simple the software is and maddeningly difficult to get it all to work well. You have software that helps you configure the system, making sure all the options are selected, making sure that you know what kind of battery, what kind of solar panels, the rating of the solar panels, the serial number of the electronics on the solar panels. You have software that helps administer the system both by the installer and by the manufacturer. Well, most systems have a cool little app that runs on your cell phone. There's also an application that runs on your desktop. And then you have to be able to have good communication in and out of the inverter. So there's updates, usually updates of firmware. And, installers really don't want to have to, take a little memory card and go to every single customer, plug this thing in and run an update. Those updates really have to be done best over the air seamlessly. And it's not easy to do well. And then finally, the last consideration, which is kind of really, really important from an equipment standpoint, is the manufacturer's real-world warranty. I'm not talking about the warranty that's printed on the brochure. Our battery is guaranteed for the life of you and your children, or for your life for 50 years. I'm talking about the real-world warranty, which typically is about 10 years. And they're important. I mean, has anybody ever had a dead battery? I mean, we've all experienced that. And me, most cases, almost every day as our cell phone battery dies. So you really want to make sure that your battery's manufactured by a reputable battery manufacturer, and think about the challenges or the ease with which you can get service on that battery. If it's a generic battery manufacturer, maybe from some country overseas, or a brand new manufacturer in the U.S. that really doesn't have a great balance sheet, if there's a problem with all their batteries, they're probably going to go out of business. And if it's inconvenient for them to meet their warranty obligations, let's say the battery dies after 5 years, they'll make you jump through hoops. And what are you going to do? Go overseas and get on a plane and try and get somebody to fix it? It's not going to happen. So companies like Enphase, Tesla, SolarEdge, LG, some others, they all care a lot about their corporate reputation, and they're going to give you a pretty good warranty. All right, so we talked about the equipment selection. Now, some design considerations, which may not be entirely intuitive. You have to make sure you have available wall space. These batteries are about 3 feet square, maybe about 9 inches deep, but they're going to go on a section of the wall or maybe inside the garage. You have to have room, and if you have 2 batteries, you're going to need even more room. There's going to be limitations on the electric service of your house and of the system you're putting in. Typically, most systems have a 200 amp electric service in the house, it may be difficult or impossible to put more than 2 batteries on that electric service without really upgrading it to 400 amps, which could be expensive. You have to make sure that the essential loads that you're connecting, and this is probably the most challenging thing to figure out for every system, is where are the circuits that you want to back up? Is everything in the same electric panel outside the house near the meter? Or is there a sub panel in the bedroom, a sub panel in the kitchen, and a sub panel in the garage, each of which has a couple of circuits that you have to wire in? Well, obviously, in the latter case, if you've got 3 sub panels, in the house, it's going to be a lot more electrical work to tie those things in. All right, here's my advice. If you want a system installed before fire season, I mean, we're talking about the beginning of the summer now, we got to have that system installed in the fall. Move fast. It typically takes a few months to design the system, get the permits, get it installed, get it interconnected. Sometimes, more than 2 or 3 months. It's kind of like a leaky roof. If your roof is leaking, you don't want to wait until the rainy season, till October, to start dialing for roofers, because they're going to be booked until the spring. So don't wait too long. Don't wait until we get closer to fire season. Now's the time to get this, pick out the system you want and get it scheduled. My advice, stick with major manufacturers. And my advice is stick with experienced solar and battery storage contractors, the people who are local, that are serving the community, that have good reviews. All right, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can always go to our website at cinnamon.energy and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.